This video is an exploration of the 6 all-space filling systems of the sphere family in the synergetic tin. We will search for the core structural memories that make these building patterns possible. There are 3 that fill all space by themselves: the cube, the ardodeca, and the coupler. The octa fills all of the space without gaps when paired with a tetra or a VE. If you look with eyes searching for whole systems, how the parts fit together into one synergetic whole, you will see the all-space filling properties of all the sphere family systems grow out of the relationship of the tetra and the octa when bonded together. Synergy is understanding how all the essential parts are interconnected. Lines of communication and networks is one method of connecting divergent parts into a whole. Another method is to multiply the interconnectedness of volumes by dividing the whole symmetrically. Multiplication by division is one of nature's most powerful organizing tools. Simple cell growth begins by dividing in half. We learned earlier that Buckminster Fuller rationalized basic volume measurement using the 4-sided tetrahedron with equal sides as one tetravolume. I chose the 6BB equals 12 centimeter edge tetra as the size for this volume because of its connection to the maximum reach of our all-purpose center that defines the relative size field. There are 2 other fundamental expressions of one tetravolume: the square root of 2 3BB edged coupler and the 1/4 volume module of the 6BB octa. Each is one tetravolume. The tetra is made up of 24A modules, the most effective minimum volume. The quantum volume we will mark as Q. The A mod has a twin volume, the B mod. Both are 1/24th tetravolume, which equals 1Q. Each mod has a spin with one hand marked with a positive spin X, the other hand with a negative spin O. The tetra only has A mods with 12 of each spin. The coupler uses 4 B mods of both spins and 8 A mods of both spins. 4 plus 4 plus 8 plus 8 equals 24Q equals 1 tetravolume. The 1/4 octamod has 6 B mods of both spins and 6 A mods of both spins. 6 times 4 equals 24 equals 1 tetravolume. We will explore the A and B mods in more detail in later videos. For now, we have a pair of most effective minimum volumes that build all the structures in the sphere family. The bubble family has the T mod. All space filling has original couple. If you divide the edges of a tetra in half, you will always form a half-size octa inside. On 4 of the octa's faces are 4 same-sized tetras. This is the very beginning of all space filling methods. Divide the edge in half again, and you have 1/4 divisions of the tetra. It is much easier to see the interconnectedness at this 1/4 division. 1/3 is another primordial division. Divide the edge of the octa in 1/3 segments, and you see the tetra-octa combo. The last primordial division is the GR, the golden ratio of the bubble family. Dividing the edge of the octa by the standard GR squared segments constructs the icosa inside the octa. We will explore these relationships in other videos. For now, we'll focus on the sphere family. There are 2 examples of how the cube's all space-filling properties grow out of the synergy, the interconnectedness between the tetra-octa. We know 2 tetras arranged in the duotet arrangement define the 8 outside corners of the cube. The volume difference between the duotets and the outside cube are 12 1/4 octas with 1 tetravolume. The cube is really a collection of tetra-octa parts. Earlier we learned a tetra surrounded by 4 1/8 octa mods form a cube. This is the second example of how the cube is made of parts of the tetra and octa. If you connect the cube center to its outside corners and then turn those modules inside out, you form an ardodeca. We're building a genealogy of interconnectedness that explains why synergy is in all fundamental structure. The R-dodeca in reality is the containment field around a sphere whose radius is 1/2 the long axis of the dodeca. This system shares all the self-organizing properties of a sphere with the convenience of flat sides. It turns out that any R-dodeca has an octa that fits exactly inside it, so that the structural memory of the octa actually defines the sphere and the R-dodeca. The volume difference between the R-dodeca and the octa inside are 8 1/4 Tetra mods on each face of the octa. The Tetra-octa combination is at the heart of the sphere's structural memory. The coupler is really the containment field around an R-dodeca. Divide the edges of the half-diamond shapes of the coupler in half and you construct an R-dodeca. Inside the R-dodeca is an octa, so inside any coupler is an octa. The Tetra-octa combination forms the all-space-filling properties of the cube, the R-dodeca, and the coupler, as well as organizing the self-organizing properties of the closest backing of same-size spheres. The last all-space-filling combo is the octa VE. We begin to understand this relationship with the 3BB equals 6 centimeters octa surrounding our all-purpose center. On each face we construct the same size VE with the volume between them filled with octas. Or on the outside corners of a 6BB VE, construct 12 3BB VEs with their octa counterparts. The octa's structural memory connects these two fundamental structures with all the others we have talked about. What these all-space-filling systems tell us is that everything is connected to everything else. On the most fundamental level of structure, each essential part knows its exact relation with all the other parts. Change one and they all change in unison to maintain a constant relationship. The tetra and the octa are the beginning of essential parts.